Students, coming to the next compound under group 17, so that is hydrogen chloride. In the last we learnt about chlorine, right? So hydrogen chloride, as we already know, it is having a chemical formula that is HCl, alva? So one hydrogen and one chlorine. Firstly, we have preparation. Coming to the laboratory preparation, that is we are going to prepare by heating sodium chloride with concentrated H2SO4. ಓಕೆನಾ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ನ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ H2SO4 ಅಲ್ಲಿ ನಾವು ಹೀಟ್ ಮಾಡಿದಾಗ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಸೋಡಿಯಂ ಬೈಸಲ್ಫೇಟ್ ಆ್ಯಂಡ್ HCl. ಸೊ HCl we are going to get a byproduct. ಓಕೆನಾ ಸೊ we are going to heat sodium chloride in presence of concentrated H2SO4, we are going to get HCl. Similarly, that sodium bisulfate undergo heating, that is in presence of NaCl, we are going to get sodium sulfate and HCl. Okay na? So from NaCl with concentrated H2SO4 and NaHSO4 with NaCl, we are going to get HCl as a byproduct. So this is the simplest laboratory method of preparing HCl. Okay na? Next we have a properties, that is physical properties. It is a colorless and pungent smelling gas, as you already familiar with this acid alva, hydrogen chloride ಅಥವಾ hydrochloric acid ಅಂತಾನೆ ಕರಿತೀವಿ. So it is a colorless and pungent smelling gas and it easily liquefies and its boiling point is 189 Kelvin and freezing point is 159 Kelvin. Okay na? So it easily liquefies to colorless liquid, whereas it freezes to white crystalline solid. Okay na? So this is about the physical properties. Next, coming to the chemical properties. Next we have chemical properties. Nextly we have chemical properties. Under that, firstly, that is acidic nature. So this hydrogen chloride is easily soluble in water and it easily ionizes. Okay na? It will easily dissociate into its ions. Okay na? That is HCl combines with water, means that undergo hydrolysis reaction and it undergo ionization, that is H3O plus and Cl minus. Okay na? Hydronium ion and chloride ion we are going to get. Here the Ka value is equal to 10 to the power 7. Okay na? So what do you mean by Ka? Ka is nothing but the dissociation constant, right? So particularly the high value of this Ka, which indicates that is it is a strong acid in water. Okay na? So strong acid in water anta heli indicate ಮಾಡುತ್ತೆ. Clear? As we already know, we have strong acids, that is sulfuric acid, hydrochloric acid and HNO3 alva. So here also it easily undergo hydrolysis process and ionizes and it is having a value 10 to the power 7. Okay na? So that is dissociation constant is very high. Okay na? Nextly, this HCl that reacts with ammonia. Okay na? This HCl reacts with ammonia to give a fumes of NH4Cl, that is ammonium chloride fumes generate ಆಗುತ್ತೆ. Okay na? HCl reacts with ammonia to form a fumes of ammonium chloride. Then one more property, that is aqua regia. We have a combination, that is aqua regia, that is mixing of HNO3 plus HCl in a ratio 1:3. So 1:3 ನಲ್ಲಿ ನಾವು HNO3 ಮತ್ತು HCl ನ ಮಿಕ್ಸ್ ಮಾಡಿದ್ರೆ that we are going to get aqua regia. Okay na? So what is aqua regia? It is nothing but the combination of HNO3 and HCl in a ratio 1:3. Okay na? So it is used for dissolving noble gases, noble metals such as gold, platinum and all. Okay na? So main aqua regia use anta bandre, that is used in the dissolving noble metals, that is gold and platinum. Okay na? So how it occurs, that is gold in presence of acidic media, then it undergo ionization to form AuCl4 minus and NO and 2H2O. Okay na? So in presence of nitrate ion and chloride ion and acid, I mean ಏನಂತಂದರೆ ಇಲ್ಲಿ ನಮಗೆ ಅಕ್ವಾರೆಜಿಯಾ ಅಂತ ಬಂದರೆ ದ ಕಾಂಬಿನೇಷನ್ ಆಫ್ NO3 ಆ್ಯಂಡ್ CL. ಸೊ ಈ ಎರಡೂ ಕಾಂಬಿನೇಷನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಅಕ್ವಾರೆಜಿಯಾ ಅಂತ ಹೇಳಿ ಕರಿತೀವಿ. ಸೊ ಇಲ್ಲಿ ಇದು ಅಯಾನಿಕ್ ಇಕ್ವೇಷನ್ಸ್ ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ಮೀನ್ಸ್ ನಾವು ಜಸ್ಟ್ NO3 ಮೈನಸ್ CL ಮೈನಸ್ ಆ ಥರ ಜಸ್ಟ್ ನೆಗೆಟಿವ್ ಅಯಾನ್ಸ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀವಿ. ಸೊ ಈ ರೀತಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡೋದನ್ನು ಏನಂತ ಕರಿತೀವಿ, ಅಯಾನಿಕ್ ಇಕ್ವೇಷನ್ಸ್ ಅಂತ ಹೇಳಿ ಕರಿತೀವಿ, ಆಸ್ ಯು ಆಲ್ರೆಡಿ ನೋ. ಸೊ ಗೋಲ್ಡ್ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಅಸಿಡಿಕ್ ಮೀಡಿಯಾ reacts with aqua regia to form AuCl4. ಓಕೆನಾ? ಸೊ ದಟ್ ಈಸ್ ಗೋಲ್ಡ್ ಕ್ಲೋರೈಡ್ ಅಥವಾ ಆರಮ್ ಕ್ಲೋರೈಡ್ ಅಂತೇಳಿ ಕರಿತೀವಿ. ದೆನ್ ವಿತ್ ದ ಎಲಿಮಿನೇಷನ್ ಆಫ್ ನೈಟ್ರಿಕ್ ಆಕ್ಸೈಡ್ ಆ್ಯಂಡ್ ವಾಟರ್. Similarly, we have platinum reaction, that is platinum in presence of acid and aqua regia. So we are going to get a platinum chloride complex. Okay na? 2 minus. So platinum chloride complex with the elimination of nitric oxide and water. Okay na? So this is how the role of aqua regia in dissolving noble metals, that is gold and platinum. Okay na? Lastly, we have uses. So uses and the mandre, that is particularly in the preparation of chlorine, aqua regia, then ammonium chloride, metal chlorides we are going to use HCl. Then even for the extracting glue from bones and purifying bone black. Okay na? So allu kuda ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. And in the preparation of medicines, and majorly it is used as a laboratory reagent. So next we have structure of oxoacids. Structure of oxoacids of chlorine. Okay. So structure of oxoacids of chlorine. So that is, we have 4 major oxoacids, that is hypochlorous acid, chlorous acid, chloric acid and perchloric acid. So these 4 are the oxoacids of chlorine. So coming to the structure of this oxoacids of chlorine. Firstly we have hypochlorous acid. Here the formula is HClO. Okay na? So structure anta bandre, that is oxygen is the central metal atom where Cl and H combines. Okay na? I mean attached to oxygen atom. HOCl or HClO. Okay na? So hypochlorous acid. Second one, chlorous acid. That is HClO2. So chlorous acid, HClO2. This is the structure of chlorous acid. Next we have chloric acid. Chloric acid, that is composition HClO3. HClO3. So Cl O H double bond O double bond O. Okay na? So chloric acid HClO3. Then we have perchloric acid. Perchloric acid, that is HClO4. So structure ClOH. So we have 3 double bonded oxygen atom. So perchloric acid. So the oxoacids of chlorines are hypochlorous acid HClO, chlorous acid HClO2, chloric acid HClO3, perchloric acid HClO4. So here we have different oxidation number alva. So as this oxidation number increases, the acidic strength also increases. Okay na. So among this now compare madidre, that is order of acidic strength anta consider madidre, as oxidation number increases, the acidic strength also increases. That is HClO less than HClO2, further less than HClO3 and HClO4. Okay na. So this is about the acidic strength which increases due to increase in the oxidation number. Next we have acidic strength of same oxidation number, means ಇಲ್ಲಿ ನಮಗೆ ಏನಾಗಿದೆ, ಕ್ಲೋರಿನ್ ಆಗಿದೆ, ಐ ಮೀನ್ ಆಕ್ಸೋ ಆಸಿಡ್ಸ್ ಆಫ್ ಕ್ಲೋರಿನ್. ಸೊ ಸಿಮಿಲರ್ಲಿ ವಿ ಹ್ಯಾವ್ ಆಕ್ಸೋ ಆಸಿಡ್ಸ್ ಆಫ್ ಬ್ರೋಮಿನ್ ಆ್ಯಂಡ್ ಅಯೋಡಿನ್. ಸೊ ಅಲ್ಲಿ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಇದ್ದಾಗ ಅದರದ್ದು ಅಸಿಡಿಕ್ ಸ್ಟ್ರೆಂತ್ ಇಟ್ ಬಿಕಮ್ಸ್ like this, that is HClO4 that is greater than HbRO4, further greater than HiO4. Okay na. Next order of oxidizing power. Okay na. Order of oxidizing power, that is HClO greater than HClO2, further greater than HClO3, which is further greater than HClO4. Okay na. So these two are the based on acidic strength, this is based on oxidizing power. Clear. So this is about the oxo acids of chlorine. So group 17 completed. So next we will have one concept under group 17, last concept, that is interhalogen compounds. Okay na. So under group 17 we have interhalogen compounds. So coming to interhalogen compounds. So what do you mean by interhalogen compounds? So two different halogens react with each other to form interhalogen compounds. Okay na. So ಎರಡು ನಮಗೆ halogens interact agi, I mean react each other to form a interhalogen compound. So generally the composition is like this, that is XX dash, X3 dash, XX5 dash and XX7 dash. Okay na. So here what is this X and X dash? X is a halogen of larger size, whereas X dash, it is a halogen of small size. Okay na. ಸೊ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ ಇಲ್ಲಿ ಎಕ್ಸ್ ರೆಫರ್ಸ್ ಟು ಹ್ಯಾಲೋಜನ್ ಆಫ್ ಲಾರ್ಜರ್ ಸೈಜ್. ಫಸ್ಟು ನಮಗೆ ಸೈಜ್ ದೊಡ್ಡದಿರೋದು, ಈಗ ವಿ ಹ್ಯಾವ್ ಎ ಹ್ಯಾಲೋಜನ್ಸ್ ದಟ್ ಈಸ್ ಫ್ಲೋರಿನ್, ಕ್ಲೋರಿನ್, ಬ್ರೋಮಿನ್, ಅಯೋಡಿನ್ ಅಲ್ವಾ. ಸೊ ಫಸ್ಟ್ ನಮಗೆ ಈ ಎಕ್ಸ್ ಅಂತ ಏನು ಇಂಡಿಕೇಟ್ ಆಗುತ್ತೆ, ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಹ್ಯಾಲೋಜನ್ಸ್ ವಿತ್ ದಿ ಲಾರ್ಜರ್ ಸೈಜ್. ಓಕೆನಾ, ದೊಡ್ಡದು ಹ್ಯಾಲೋಜನ್. ನೆಕ್ಸ್ಟ್ ಎಕ್ಸ್ ಡ್ಯಾಶ್ ರೆಫರ್ಸ್ ಟು ಸ್ಮಾಲ್ ಸೈಜ್ ಹ್ಯಾಲೋಜನ್. ಓಕೆನಾ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ವಿ ಹ್ಯಾವ್ ಕ್ಲೋರಿನ್, ಸಿ ಎಲ್ ಎಫ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಎಫ್ ಸಿ ಎಲ್ ಅಂತ ಹೇಳಲ್ಲ. ಅಂಡರ್ಸ್ಟುಡ್. ಸೊ ಸಿ ಎಲ್ ಎಫ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸಿ ಎಲ್ ಎಫ್ ಅಂತ ಬಂದರೆ ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಎಕ್ಸ್, ಎಕ್ಸ್ ಡ್ಯಾಶ್. ಸೊ ದಿಸ್ ಈಸ್ ಅ ಲಾರ್ಜರ್ ಆ್ಯಂಡ್ ದಿಸ್ ಈಸ್ ಅ ಸ್ಮಾಲರ್. ವಿ ಕಾನ್ ಟೆಲ್ ಎಫ್ ಸಿ ಎಲ್. ಓಕೆನಾ, ಈ ರೀತಿ ಹೇಳೋಕ್ಕಾಗಲ್ಲ. ದಿಸ್ ಇಸ್ ರಾಂಗ್. ಓಕೆನಾ, ಕಂಪ್ಲೀಟ್ಲಿ ದಿಸ್ ಇಸ್ ರಾಂಗ್. ವಿ ಹ್ಯಾವ್ ಟು ಟೆಲ್ ಲೈಕ್ ದಿಸ್, ಸಿ ಎಲ್ ಎಫ್ ಅಂತ ಬಂದರೆ ಫಸ್ಟ್ ಒನ್ ಈಸ್ halogen with a large size, second one is the halogen with the small size. Okay na. So particularly, and here X is more electropositive than X dash. One more thing, X is more electropositive than X dash. Adu one point. Okay na. Only iodine forms IF7 by combining 7 fluorine atoms. Only iodine form IF7. I mean to say X7 dash anta in ee form alli ಏನು ಹೇಳ್ತೀವಿ, ಅದು only iodine form. Okay na. That is due to a large atomic radii differences between the iodine and the fluorine. ಓಕೆನಾ, ಅಯೋಡಿನ್ ಮತ್ತು ಫ್ಲೂರಿನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ನಮಗೆ ಲಾರ್ಜ್ ಅಟಾಮಿಕ್ ರೇಡಿಯೈ ಡಿಫ್ರೆನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಓನ್ಲಿ IF7 ಎಕ್ಸಿಸ್ಟ್. ಕ್ಲಿಯರ್. ಕಮಿಂಗ್ ಟು ದಿ ಪ್ರಿಪ್ರೇಷನ್, ಹೌ ದೀಸ್ ಹ್ಯಾಲೋಜನ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪ್ರಿಪೇರ್ಡ್. ಸೊ ಫಸ್ಟ್ಲಿ CLF, CLF, that is equal volume of chlorine and fluorine combines or reacts under 437 Kelvin, we are going to get CLF. Okay na, equal volume of chlorine and fluorine under 437 Kelvin, we are going to get CLF. Next we have CLF3, that is chlorine reacts with excess fluorine. Chlorine reacts with excess fluorine around 573 Kelvin. We are going to get ClF3. Okay na? Next, ICl, that is equal volume of iodine and chlorine reacts to form 2ICl. Next we have ICl3, that is iodine combines with excess chlorine to form ICl3. Okay na? Nextly we have BRF3. So bromine reacts with excess fluorine to give BRF3. Similarly, BRF5, that is bromine reacts with excess fluorine to form 2BRF5. Okay na? So this is how we can prepare interhalogen compounds. Understood? So equal volume of chlorine and fluorine reacts under 437 Kelvin, we are going to get CLF. Chlorine with excess fluorine under 573 Kelvin, CLF3. Equal volume of iodine and chlorine, ICl. Then iodine reacts with excess chlorine to form ICl3. Bromine reacts with excess fluorine to form BRF3. Bromine reacts with further excess fluorine, we are going to get FBrF5. Okay na? This is how we are going to prepare interhalogen compounds. So ನೀವು ಇಷ್ಟರಲ್ಲೆಲ್ಲ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡ್ಬೋದು, ಹಿಯರ್ ಇಟ್ ಈಸ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ X, X dash, X, X3 dash and X, X5 dash ಅಲ್ವಾ? ಸೊ ಎಲ್ಲದರಲ್ಲೂ X is halogen with a large size, whereas X dash is halogen with the small size. ಓಕೆನಾ? ಸೊ ಆ ಒಂದು ಕಾಂಪೋಸಿಷನಲ್ಲಿ ಇದ್ದರೆ ಮಾತ್ರನೇ ಇಟ್ ವಿಲ್ ಬಿಕಮ್ ಅ ಇಂಟರ್ಹ್ಯಾಲೋಜನ್ ಕಾಂಪೌಂಡ್. ಕ್ಲಿಯರ್? Okay. Next we have a properties, that is particularly these are covalent molecules and they exhibit diamagnetic in nature. Okay na, magnetic property anta bandre they exhibit diamagnetic in nature. These are volatile solids or liquids at 298 Kelvin. I mean normal temperature alli these are volatile solids or liquid, except chlorofluorine, that is ClF. Okay na, that is a gas. Next, reactivity, how it reacts with other. Okay na? So interhalogen compounds are basically more reactive than halogens. Okay na? Halogens na compare ಮಾಡಿದ್ರೆ these interhalogen compounds are more reactive. Okay na? Except fluorine. Except fluorine, these interhalogen compounds are more reactive. Why it is more reactive? Because XX dash bond in interhalogen are weaker than XX bond. Okay na? So for example, ನಮಗೆ interhalogen compound ಅಂದರೆ XX dash bond ಇರುತ್ತೆ. Normally halogen ಅಂತ ಬಂದರೆ XX bond. ಓಕೆನಾ? ಸೊ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಈ ಎರಡಕ್ಕೂ ದಿಸ್ ಇಸ್ ಅ ವೀಕರ್. ಓಕೆನಾ? ಸೊ ಇದು ತುಂಬ ನಮಗೆ ವೀಕರ್ ಆಗಿರೋದ್ರಿಂದ ಹೈಲಿ ರಿಯಾಕ್ಟಿವ್, ವೀಕ್ ಆಗಿರೋದ್ರಿಂದ ವಿ ಕ್ಯಾನ್ ಈಸಿಲಿ ಬ್ರೇಕ್ ದ ಬಾಂಡ್ ಅಲ್ವಾ? ಸೊ ಹಾಗಾಗಿ ದೀಸ್ ಆರ್ ಹೈಲಿ ರಿಯಾಕ್ಟಿವ್. ಓಕೆನಾ? interhalogen compounds are more reactive, that is due to presence of weaker XX bond. ಓಕೆನಾ? ಸೊ ಕಂಪ್ಯಾರಿಟಿವ್ಲಿ XX ಬಾಂಡಿಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ನಮಗೆ XX ಡ್ಯಾಶ್ ಬಾಂಡು ವೀಕರ್ ಆಗಿರುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ ನಮಗೆ ದೀಸ್ ಆರ್ ಮೋರ್ ರಿಯಾಕ್ಟಿವ್ ಇನ್ ನೇಚರ್. ಓಕೆನಾ? ಮೋರ್ ರಿಯಾಕ್ಟಿವ್. ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ವಿ ಹ್ಯಾವ್ ICl is more reactive is more reactive than I2. ಹೌದು ತಾನೆ? ಸೊ ಐ ಸಿ ಎಲ್ ಬಾಂಡು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಐ ಬಾಂಡ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ನಾವು ಇದು ವೀಕರ್ ಅಂತ ಹೇಳಿ ಹೇಳ್ತೀವಿ. ಓಕೆನಾ? ಸೊ ದಟ್ ಈಸ್ ಐ ಸಿ ಎಲ್ ಬಾಂಡ್ ಈಸ್ ವೀಕರ್ ದ್ಯಾನ್ ಐ ಬಾಂಡ್. ಹೆನ್ಸ್ ಐ ಸಿ ಎಲ್ ಈಸ್ ಮೋರ್ ರಿಯಾಕ್ಟಿವ್ ದ್ಯಾನ್ ಅಯೋಡಿನ್. ಅಂಡರ್ಸ್ಟುಡ್? ಸೊ ಇಂಟರ್ ಹ್ಯಾಲೋಜನ್ ಕಾಂಪೌಂಡ್ಸ್ ಆರ್ ಮೋರ್ ರಿಯಾಕ್ಟಿವ್ ದ್ಯಾನ್ halogen compounds. ಓಕೆನಾ? ಸೊ ಇದರಲ್ಲಿ ಎಕ್ಸೆಪ್ಷನ್ ವಿ ಹ್ಯಾವ್, ದಟ್ ಈಸ್ ಫ್ಲೂರಿನ್, ಎಫ್ ಅದು ಕಂಪ್ಯಾರಿಟಿವ್ಲಿ ನಮಗೆ ಎಕ್ಸೆಪ್ಷನ್ ಇರುತ್ತೆ. ದೆನ್ ನೆಕ್ಸ್ಟ್ಲಿ ವಿ ಹ್ಯಾವ್ ಹೈಡ್ರಾಲಿಸಿಸ್ ಆಫ್ ಇಂಟರ್ ಹ್ಯಾಲೋಜನ್ ಕಾಂಪೌಂಡ್ಸ್. ಸೊ ವಾಟ್ ಯು ಮೀನ್ ಬೈ hydrolysis? So hydrolysis is nothing but the what? Addition of water to the inter halogen compounds. So see here, hydrolysis, particularly these forms undergo hydrolysis to form respective ions. Okay na? I mean respective anions we are going to get. That is the general reaction antandre, that is XX dash plus water, it will give rise to HX plus HOX dash. Okay na? So X dash H combines with water to form HX and HOX. So it will form a halide. Okay na? So halide ion formation agutte. Clear? So ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ಯಾವುದು ಸ್ಮಾಲರ್ ಅಯಾನ್ ಇದೆ, ಐ ಮೀನ್ ಸ್ಮಾಲರ್ ಸೈಜ್ಡ್ ಹಲೋಜನ್ ಯಾವುದಿದೆ ಅದ್ರ ಜೊತೆ ನಮಗೆ ಹೈಡ್ರೋಜನ್ ಅಟ್ಯಾಚ್ ಆಗುತ್ತೆ. ಅಂಡರ್ಸ್ಟುಡ್? ಸೊ ಸ್ಮಾಲರ್ ಅಯಾನ್ ಯಾವುದಿರುತ್ತೆ ಅದ್ರ ಜೊತೆಗೆ ನಮಗೆ ಹೈಡ್ರೋಜನ್ ಅಟ್ಯಾಚ್ ಆಗುತ್ತೆ. ಸೊ ವಾಟರ್ ಅಂತ ಬಂದಾಗ ನಮಗೆ ಸ್ಪ್ಲಿಟ್ ಆಗುತ್ತೆ, ದಟ್ ಈಸ್ HOH. ಸೊ ದಿಸ್ H ಕಂಬೈನ್ಸ್ ವಿತ್ X, this OH combines with X dash. Okay na? So H X, next HO X dash. So ಈ ರೀತಿ ನಮಗೆ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಸಿಮಿಲರ್ಲಿ ನಮಗೆ ಏನು, ದಟ್ ಈಸ್ XX dash ಜೊತೆಗೆ ಇಟ್ ವಿಲ್ ಫಾರ್ಮ್ ಎ hypohalite. This is hypohalites, that is hypohalite. HOX dash ಅನ್ನೋದು hypohalite. With respect to X3 dash-ಗೆ halite. Then X5 dash-ಗೆ halate. Then X7 dash-ಗೆ perhalate. ಸೊ ಈ ರೀತಿ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಕ್ಲಿಯರ್? ಸೊ ಹಾಗಿದ್ರೆ ಫಾರ್ಮುಲಾ ಅಂತ ಬಂದರೆ ಹ್ಯಾಸ್ ವಿ ಆಲ್ರೆಡಿ ನೋ, ಹೈಪೋಅಲೈಟ್ ಅಂತ ಬಂದರೆ HOX dash. ನೆಕ್ಸ್ಟು ನಮಗೆ ಇಲ್ಲೇನಾಗುತ್ತೆ, HOX3 dash, HOX5 dash, HOX7 dash. ಓಕೆನಾ? ಸೊ ಈ ಫಾರ್ಮಲ್ಲಿ ಇರುತ್ತೆ. ಅಂಡರ್ಸ್ಟುಡ್? ಸೊ interhalogen undergo hydrolysis reaction to form halides with the hypohalite, halate, perhalate. Okay na? So ee form alli namige products barutte. Clear? So this is how hydrolysis of interhalogen compounds takes place. Nextly we have coming to the structure. So particularly this XX3 dash structure, that is bent T-shaped structure, whereas XX5 dash, it is square pyramidal. Then XX7, okay na? So dash, that is nothing but IF7. ಓನ್ಲಿ IF7 ಹಯೋಡಿನ್ ಮಾತ್ರ ತಾನೇ ಫ್ಲೂರಿನ್ 7 ಆಟಮ್ಸ್ ಜೊತೆ ಕಂಬೈನ್ ಆಗಿ ಈ ಫಾರ್ಮಲ್ಲಿ ಸಿಕ್ಕೋದು. ಸೊ ಓನ್ಲಿ IF7, that is pentagonal bipyramidal structure. Okay na? Then lastly coming to the uses. So these are used as a non-aqueous solvents. Then these are very useful fluorinating agents. Okay na? Then particularly ZlF3 and BrF3 are used in the production of UF6 in the enrichment of uranium 235. ಓಕೆನಾ. ಸೊ ಅದರಲ್ಲಿ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ClF3 ಆ್ಯಂಡ್ BrF3. ಓಕೆನಾ. ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ದಿ ಯೂಸಸ್ ಆಫ್ ಇಂಟರ್ ಹ್ಯಾಲೋಜನ್ ಕಾಂಪೌಂಡ್ಸ್. ಸೊ ದಿಸ್ ಕಂಪ್ಲೀಟ್ಸ್ ಯುವರ್ group 17 element. In the next we are going to deal with the group 18 elements.